HCl is an acid. Is it going to accept or donate protons? Donate protons. Okay, so it's going to donate it to the H2O, which is going to turn into what? H3O, more information. Plus, yeah. And then what's going to be left over? Chloride ion. Okay, how happy with that? Maybe I should do it on the TV so you can actually see it on the TV. You want to see it on the TV? I can do that. Because then at least maybe you all can look at it a little bit better. Yeah, I know. You want to run up to the front and go grab the remote, please? Oh, that's the main. Whoops, no wonder I'm not doing it on. Okay. We'll start gathering around this TV because eventually we will go through this one. TV remote? Any TV remote? No? Behind the boards, maybe? No? Yeah? Bit closer. Never mind. I just turn it on here. Why are you not working? Piece of... Come on. Right. We're in Science 3, yeah? Okay, here we go. That'll do. Okay, so happy with the idea about it's Cl minus as the thing that's left. Okay, so therefore you need to be able to identify conjugate acid-base pairs. How do you identify a conjugate acid-base pair? You look for things that differ by one hydrogen. Okay, so here we have one there. They differ by one hydrogen. Okay, and things that are over here and here, they also differ by one hydrogen. In that test there, we had the CO3 and the HCO3 minus as the thing that differed by one hydrogen, and that was the conjugate acid-base pair. But you need to be able to identify if things are show an acid-base pair somewhere. Okay, we can identify which one's the acid and which one's the base. This HCl, is that the acid or the base in that pair, Talia? The acid, good, and that makes this the conjugate base, okay? And then the H2O is what then? The base, okay? And that makes that the conjugate acid. Are we happy with the idea that H2O is a base? Or are we happy with the idea that H2O is acting like a base? What's the difference there? What's the difference to say that H2O is a base and H2O is acting like a base?
If you say it's acting as a base, that means it can also act as an acid.
Good, yeah. So its nature, water in its nature by itself is not a base. Water is neutral substance because by itself, sitting all alone, it will not produce OH minus ions. It will not accept protons. I mean, it has the ability to accept protons, right? But it generally by itself doesn't do so, right? But when you put it with other stuff, it can act like a base, okay? So that's conjugate acid-base pairs, right? You need to know about those. Are we happy with those ideas, or do you want a couple of more examples? That one's a fairly straightforward one. Let's do one more example. NH3, okay? Let's say that I react it with HCl. Okay, is that an, what's the acid there? Rivera? The HCl, okay? So that's going to donate a proton. What is it going to donate the proton to? The NH3, which is going to turn it into what, Bella? NH4, whoops. NH4 plus, okay? And what's going to be left over? The Cl minus, okay? Cool, so this is the ammonia and the ammonium ion pair. Okay, so you need to be able to recognize ammonia will act like a base and form ammonia instead of water, which is what most of the time it does. Okay, when you react an acid and a base, it doesn't necessarily always produce water. When the base is ammonia, it will produce ammonium. Or if the acid is if ammonium, which is this one here, if the acid is ammonium, then it won't necessarily produce water, right? So that's what the ammonium video was about. I wanted to just make sure that you understand that if I say that I put some ammonium nitrate with sodium hydroxide, what will be the reaction? What will be the products produced from there? So first of all, what's the formula for ammonium nitrate? Not sure? Okay, so the ammonium, what's the formula for ammonium? NH4 plus. And what's the formula for nitrate? NO3, more information. 1 minus, 2 minus. 1 minus. 1 minus. Okay, so if it's 1 positive and 1 minus, so what's the formula for ammonium nitrate then? Put them together. NH4, so it's a 1-to-1 ratio. It's going to be NH4NO3. Okay, then sodium hydroxide, NaOH. Okay, those two added together are going to form what? Carbon? When you react those two together, what is it going to form? What are the products going to be? Yep, so what's the salt produced? NaNO3, good. That's the salt. And water. And what? Not NO3. No, okay, because the NO, this part here went to here. Okay, so really we've got this part here that's left. Okay, because one of those hydrogens went to this hydroxide to form this water. Okay, so what's left over then? The other NH3, which goes all the way over here. Oops. Okay, NH3. Happy with that? Okay, so this is type of reaction where ammonium is acting like the acid. You need to know how to write just balanced equations for it and understand that part. Okay, cool. So that is ammonium and ammonia, right? That was the Bronsted-Lowry thing. What was next after the Bronsted-Lowry thing? It was ammonia and ammonium, and then after that it was salts, acidic salts and bases. Okay, so have you started to memorize the acidic and basic salt table? You have to memorize that because there's no other way, like no other good way to know whether things are acidic, basic, or neutral. Okay, so you should just go back and find that table and just test yourself. So NO3 minus, acidic, basic, or neutral? So hands up who feels that they've reasonably memorized most of that table. A little bit? Yeah? Okay? Yeah? No? No? Okay, so you really have to go back and memorize that table. There's no other way to show it. Okay? So this NO3 is neutral, which means that when you react it with water, it's not going to accept or donate a proton. Okay? But there are other things like SO4 2 minus. What's that one? Acidic. That's not going to be acidic. That's going to be basic. General one about acidic is that it has to have a hydrogen there so that it can donate the proton. All right? But you need to memorize it. If you wanted to show that this is basic, you have to show it with reacting with what? Reacting with what? Water. Okay? So you react it with water. Okay? And then you can show that it's got a basic nature. If it's got a basic nature, is it going to accept or donate a proton? Basic. Basic means bases accept protons. Okay? So if it accepts the proton, what's it going to turn into? Not H2SO4, it's going to accept one proton only. So what is it going to form? So you've given it 2 hydrogens, you only need to give it 1 hydrogen. You said HSO4, more information? Negative there. Okay, so it's accepted 1 proton from it. Okay, so then you have to go and do the next part, which is the OH minus, which is from the water, and then you can identify conjugate acid-base pairs. Okay, so first part is to memorize all of these, right? And then you need to be able to apply the idea that, okay, I need to show it that it's basic by reacting it with water and showing that it does so. Once you do that, you also have to state that produces OH minus ions, and then you have to say that the OH minus ion concentration is greater than the H3O plus concentration. Okay, because this concept here, where one is greater than the other, is the definition of its basic. So if it says, why is sulfate ion basic? Okay, this is what it does with water, and so therefore it produces OH minus ions, and therefore the OH minus ions are greater than H3O plus. Okay, let's try another one. Okay, let's do sodium hydrogen carbonate. Okay, sodium hydrogen carbonate. Is that acidic, basic, or neutral? Anyone? Anyone know? Okay, so, sorry? No? Okay, so first of all, you need to understand that it's made up of two parts, sodium and hydrogen carbonate. And then you have to be able to say that, okay, out of those two, which one is acidic and basic or neutral? Or you have a look at them. Na plus, if you look at that table, it's neutral. Okay, HCO3 minus, that one is acidic. Okay, that's what we did the thing on there. Anyway, so we need to show that it's acidic by showing its reaction with what? With what? Water, yep. So we show it reacting with water. Now we have to show that it's acidic. So if we show that it's acidic, what do we write next? H3, H3O, more information?
Negative.
Not negative. Positive, okay, so that's the acid part, plus CO3, more information? Charge?
Negative.
Not negative. 2 minus, okay? So the idea is that when you move a proton from one thing to another, you are losing a positive charge, okay? So if you lose a positive charge, it's going to become one less, one more minus, okay? The thing that gains the charge here becomes one more positive, okay? So that's how you differentiate between conjugate acid and base pairs as well, that they've got a difference in charge of 1, okay? Right? So, and then what would you have to say after that? What's the last thing you have to say? Produces H3O plus, and therefore H3O plus ion concentration is greater than OH minus ion concentration. Okay? Right? One last time, let's see if we remember the steps. Okay, so if I say calcium phosphate. Calcium phosphate. What would be the charges or the ratios on this one? Calcium phosphate. What should be the little subscripts there? Calcium should have what? What do you think? Okay, well, calcium is 2 plus. Yep. And phosphate is 3 minus. So if calcium is 2 plus and phosphate is 3 minus, what will be the two numbers that we put there? Talia? Natalia.
I don't know what you mean.
So what's the formula here? Because that's not the formula. It's missing some of the subscripts. So if I say that calcium is 2 plus and phosphate is PO4 3 minus, I have to put them two together.
Do you put the 3 under the calcium?
Yeah.
PO4 in brackets and then 2.
Perfect. There you go. Good. Excellent. Right. So that's the calcium phosphate, and then we have to identify. What's the next step? We have to identify what?
Identify which ones are neutral and which ones are acid.
Good. So split the thing up and identify its component ions are acidic, basic, or neutral. Oops. Okay. So then you would hopefully remember the ion table, and you would say that calcium is neutral and phosphate is basic. Okay. Once you've worked out the formula, split it into two ions, and then worked out which one's acidic, basic, or neutral, what's the next step, Abira? React it with water, okay? And only the basic or acidic one. So the PO4 3 minus reacts with water, okay? And what is it? What's one of the things that it forms, Bella? HPO4 2 minus, and another thing? Sorry? OH minus, excellent. Once you've got that, you should write down what after that? It produces what? Produces OH minus, okay? So that you say that it produces OH minus. And then you have to say after that, what?
OH minus is greater than H3O.
Yep. OH minus is greater than H3O plus. OH minus is concentration. Now it has to be concentration as well, is greater than H3O plus. Okay? All right. So those are the steps there, yeah? Step 1 was identifying the formula from the name. Step 2 is split the things into the two parts and work out if they're acidic, basic, or neutral. Step 3, react it with water in a hydrolysis reaction, depending on what it is, whether it's acidic, basic, or neutral. Then step 4, you say that it produces the, say that it produces the OH minus or the H3O plus, and then you say that that's the last thing. So there's 5 different things you have to do there. Okay? All right? So that is the acidic, basic, or salts. You have to memorize that table. Okay? There's no other way about it. Right? And then finally, the last topic that we were going to cover, I can't remember what it was KW, salts and, oh no, that's it. Yeah. Salts and Ka and Kb. Oh yeah, so Ka and Kb. All right? So, the idea is that K values represent how much a reaction produces products compared to reactants, okay? A reversible reaction. So if I say that these two reactions here, this one here, and that one here, they're both basic, yeah? Yep, they're both basic. So if I had 0.1 molar SO4 2 minus and 0.1 molar PO4 3 minus, so that's saying I've the same concentration of those two things, right? I've dropped them into a solution, and then if I was to say which one is more acidic, which one is more basic, which one has a higher pH, it would depend on the K value. Okay, so if I said that this K value had a value of like 8, and this had a K value of 10, okay? If this one had a K value of 8, this one had a K value of 10, which one do you think is going to be more basic? What do you think? 10. The 10 one. Why?
High pH.
Okay, so the K value tells you what? It tells you how many reactants and products there are, comparative. So out of these two reactions, which one has more products? The bottom one. Okay, the bottom one has more products. How do you know that? Because the K value is higher. If it has more products, it has more OH minus ions. Okay, it has more OH minus ions. If it has more OH minus ions, therefore the concentration here is going to be lower than the concentration here, which means that there is more of those OH minus ions down there, and so therefore you're going to end up with a higher pH on this one here compared to that one there. So those K values just show you the ratio of products to reactants, right? And then you can use that to work out which one has more OH minus or H2O plus, and then can comment on their pH relative to each other. Okay? All right. Questions? Give me 3 questions about this topic. 1.
Did you go through complex ions?
Complex ions. And salts and complex ions?
Yeah.
Okay, cool. Let's go do that. Okay, cool. So if you've watched the video about salts and complex ions, the idea is that aluminium 3 plus and iron 3 plus are acidic ions. Okay, but it's really difficult to be acidic when you have no hydrogens to do anything there. Okay, so the idea is that the aluminium ion itself is very positive. It's 3 positive, it's quite positive in the general scheme of things. All right, so what happens is that water will be attracted to it. Okay, so water molecules will be attracted to it, but they're going to be attracted to it in a certain way and in a certain arrangement. Okay, so would they be arranged this way around it or this way around it? Which one, the top or the bottom one? What do you think? Why the bottom one?
Because the O is one negative, so it's attracted to the positive.
Good. The O is the negative end and the H is the positive end. And so therefore the positive end wouldn't be attracted to the negative, the negative end would be attracted to it. So the idea is that this very positive ion attracts a whole bunch of water molecules around it. Okay? Now, those water molecules around it are effectively stuck to them because of the very strong attraction. Okay? Now, I don't know if have I drawn 6? No, I haven't. One more. Okay? So 6 water molecules generally attract to it all around. Left, right, top, bottom, forward, backwards. Okay? That's 7? Whoops, too bad. All right? So, what happens then is that this entire thing becomes a 3+ ion. Right? Because it makes, the waters are effectively stuck to it, so they always move together. So therefore, that entire thing is a 3+ ion. Yeah?
Do they form bonds?
No, they don't really form bonds. They're just really strongly attracted to it. Yep.
Is it always going to be 6H2O?
6H2O or some varying number of ammoniums as well. Generally, it'll tell you how many, and then you work it out from there. All right, cool. So this now has the ability to donate protons, because if I add it with water now, it's going to form, one of these is going to fall off. So maybe this one here. This one here is going to fall off. So I'm going to end up with 5 water molecules and 1 OH- molecule, right? So those are all going to still be there. So it'll be, whoops, Al, and then bracket H2O 5 OH, all in one big square brackets. And what do you think its charge is going to be? It's lost a hydrogen here, and it was originally 3+. So what do you think its charge is going to be? 2+. Good. Okay, because it's lost the hydrogen, it's going to have 1 less positive charge. Okay, if you're wondering what this one is written as, it's Al bracket H2O bracket 6 in square brackets 3+. Okay, and also forming H3O plus to make it acidic. So this whole thing here is a complex ion. This is also a complex ion. Okay, but the idea is that this aluminium and iron form a complex ion to allow it to give protons to other things, which is why it's acidic in nature. Okay, cool. That was one question. 2 more questions about any of these topics that we've covered. 2 more questions, come on. You have to ask questions. Will.
In the ammonia and ammonium,
Yep.
there was notes about like how the different states will react to produce.
Yep. Okay, so the idea that ammonium generally form, so when you have ammonium and it reacts with something, it's going to form ammonia, right? So here is ammonium, it's going to form ammonia, right? Now, depending on the states that were present here, so whatever state that was and whatever state that was, it will determine the state here, okay? So if you're doing this reaction in solution, the ammonia will go into solution. If you're reacting it in anything other than solution, the ammonia produced is going to be formed as a gas. If it's anything other than in a solution of some sort, then it's going to react as a gas, right? The other thing is also that if you have ammonia and you react it as a gas, right? Unless you produce water, it's not going, or unless you produce water or it's anywhere near water, it's going to form a solid. So this NH4Cl is going to actually be a solid instead of in 2 ions if it was 2 gases, right? Because these 2 gases combine together to form an ionic compound now. So this is now an ionic compound. So therefore that ionic compound at room temperature, because these are gaseous things, unless it's at super high temperatures, right? That is occurring at room temperature. Those 2 gases react. Now suddenly turns into an ionic compound. It suddenly turns into a solid. Okay? That's what it's going to be there. Okay?